Thank you. I'm the design partner for HOK's New York office, and I chair the design board for all of HOK, looking for the best designers to join our practice worldwide. I wanted to start today with a brief slide about some photographs that appeared in the New York Times last week, which is a major driver behind our practice in New York and at HOK being a global leader in sustainable design. These are images of the smallest polar ice cap in September, on September 16th, which is the day that the ice pack begins to reform. And climate change is real, and what we're trying to do at HOK is move beyond passive design and zero carbon or carbon neutral buildings to find a way to design buildings that minimize the impact on the built environment. It's a little hard coming from a session talking about 1,000-meter towers. I'm going to talk about four projects that are essentially 200 to 250 meters. They're background buildings. They're not trying to be the tallest buildings in the world. But it's an exploration that we're going through working with biologists in trying to define architecture in a way where the form is developed and the patterns are developed by images and form and the way that biology functions. So we have a biologist at our design table as part of our conversation when we start our projects. And we're working with the Biomimicry Guild, Janine Benyus, out of Montana, and we have a relationship with them that we've had for 3 or 4 years, where we actually look at each project through a series of lenses, and I'm going to go through some of those lenses. Earlier we talked about the triple bottom line in the presentations earlier today, but what we're trying to do is we're trying to look at the impact of our buildings and looking at ways that we can look at biology to inform the design in terms of energy reduction, passive design, structural design, our building skins. And our goal is that when the city and the forest are functionally indistinguishable, that's when we'll find a sweet spot in the design of our buildings. And that's what we're trying to do working with the Biomimicry Guild. Our planning group and architectural group have invested a lot of time and energy in developing a process we call fully integrated thinking. It was presented earlier today with the 3 circles that talked about the social and economic and environmental impact of the projects. And we need to look at the systems of our buildings and find ways. This is Atlanta, and the Amazon on the right, and the Atlanta is on the left. We need to find ways where the buildings and the landscape become one from a functional standpoint and from a design standpoint. So if you look at nature, we have 3.8 billion years of experience to learn from on how natural organisms adapt. And then if you look at the number of species in the world that have made that adaptation, there's 30 to 100 million species on the planet today. And what we're trying to do is adapt our design based on specific sites so that our buildings are responding more efficiently to the environment. We look at this through 15 different lenses, and we set up this criteria for all of our projects. We talked about environmental, social, and economic. Within each of those categories, we look at the ecostructure, water, atmosphere, materials, energy, food. On the social side, we look at how we can make a community. How do we make vertical cities? One of the strongest beliefs we have is that when these buildings meet the ground, instead of meeting the sky, they actually have to be planted in the city. And the biggest problem we have in China and the projects I'll show you in Korea is really the superblock and how you can break down the scale of the superblock. We need to look at the cultural impact of our buildings, the health of our buildings, the educational opportunities, how these projects are governed, integrated with transport, and how do we create shelter for more of humanity. And then, of course, there's the economic side of all of our projects. We want them to be built, and there has to be a good return on investment for our clients. So we're investing a lot of time and energy in trying to define the characteristics of what we call biomes, the major biomes of the world. Here in Shanghai, we're actually in the equivalent of the Atlantic temperate forest. So working with the Biomimicry Guild, we're actually looking at the flora and fauna and trying to document how these species adapt to each of these different major climates. And then when you look at how these organisms function, we're looking for ways within the design solutions to look at photosynthesis, look at the cellular structure of these organisms, looking at how they function. And looking at those 15 lenses, each of our projects is trying to integrate some of the thinking, some more successful than others, but to integrate how we can make the architecture indistinguishable from the landscape. So some examples in the non-architectural world are, if you look at the bill of a hummingbird and you look at the nose of a high-speed train, this is how basically humans are replicating what one sees in nature in terms of looking for how form is made. We're doing a new city in India for 2 million people. And looking at the land use, the first thing we do is we look at what the biologists say is there in the existing condition, the topography, the flora, the fauna, the biology, what the natural organisms are, and then how we can adapt the architecture to be compatible and precisely fitting within that particular context, so that the line of horizontal design and vertical design is indistinguishable. We're looking at vertical farming. We're looking not just at infrastructure and planning, but we're looking at wind patterns, we're looking at solar orientation, we're looking at vertical distribution of uses. And as we develop our urban designs and then our towers, and I'll get into the towers in a few minutes, our designs are a little bit more organic because we're looking at the wind direction, the solar direction, and the vertical displacement of people as they're moving through the buildings. And it's really all organized around places for gathering. So we're looking for different ways that we can inform our form making that's a little less arbitrary than just the sculptural iconic effects of the buildings themselves. So that's a little background about our relationship with biomimicry and our fully integrated thinking process. And I want to use New Songdo City as an opportunity to walk through 4 projects that we've done where we've tried to apply and explore some of these principles into the design of these projects. New Songdo, as many of you may know, was master planned in 2001, 2002 by Gale and by Cohn Pedersen Fox. We were brought in after the master plan was complete to develop all the buildings along Central Park, which was a great opportunity to build and design almost 9 million square feet. 7 million of it was built in only 4 years. So we applied the principles of biomimicry to these 3 major superblocks and 1 convention center hotel. On the left side of the slide, you see Central Park 1, D22, which we call the basket weave buildings. In the middle, you see D23 Central Park 2, which we call the bamboo towers or dancing towers. On D24, you see the curvilinear towers. There are twisted towers, but with a very strong rigor in terms of how they're designed. And then in the little corner, you'll see a trapezoidal building, which is the Convention Center Hotel. So in looking at the first set of 2 million square feet of architecture, we wanted to look at basically self-shading. We wanted to look at the biology of how buildings actually create self-shadows on themselves. And we wanted to create some very elegant, simple towers and develop one detail very well. We reduced the heat gain on the building by about 10% by creating these shells for making shadows. The towers themselves are very simple with 6 units per floor. But what we really wanted to focus on was this outside 1.5 meters of the building, which in Korea is given to the basically purchaser of the unit for free. It's outdoor space that can then be enclosed. So we wanted to look at that outside 1.5 meters and see how we could articulate the facade, not unlike a cactus, not unlike a basket with the palm fronds, where we can create some energy savings by shaping the facade. And so around the perimeter you see that. And it's a very simple structure with green roofs, and we spent a lot of time focusing on the development of the interior portion of the landscape for the superblock itself. These projects were completed last year, and they leased within 22 hours. They were all sold. And the notion here was that we actually created these shadows and created natural ventilation for all the units as well, creating iconic architecture, very simple, one very elegant, well-detailed connection. And we created the shadows on the building that reduced the heat gain for the occupants. With a very welcoming pedestrian presence. For the next set of towers, D23 Central Park 2, it's another 2 million square feet. We looked at the cellular structure of some of the elements you find in the ocean, and on the right you can see some chimneys that we've actually designed for an institutional project in Saudi Arabia, where we created these chimneys that are drawing the air through the courtyards of our buildings. This is for King Abdullah University of Saudi Arabia, which is the world's largest LEED Platinum project. It's 5 million square feet. It's a $5 billion project. And the key to the success in terms of the biomimicry and the sustainability was the natural ventilation by creating these chimneys that draw the air through the major public spaces, and the buildings sit underneath it. So we were doing this about the same time as we were developing the design for the next 2 million square feet in Songdo City. And when you're looking at the economics of residential in Korea, the marketing group says one has to extrude the typical 5 units or 6 units per floor vertically all the way up. So all the towers we saw were extrusions from the ground all the way to the top. So we met with our structural engineers and we said, how much can we shift the formwork to create something that seems a little bit more organic with the diagrid expressed on the facade? And we created these 3 towers, studying ways that they can interlock with one another and still satisfy the marketing group. The baseline for the cost we used for each of these projects were the basket weave towers, the first 3 that I showed you. The cost incremental for doing this structural change was about 5% addition to the cost of the previous buildings. So we weren't studying shading here, we were studying looking at nature and looking at the structure and how we could shift it in such a way to create an iconic building for the client. We looked at ways we could optimize the structure because the other aspect of what we're trying to do is we're looking for integrated structural and architectural solutions. And so how one actually transfers the loads becomes a cost issue. So in these towers, which range from 48 to 58 stories, we essentially looked at ways that we could create an iconic image, express the diagrid of the facade itself, meet the marketing demands of unit types that are identical all the way up, and then develop an affordable enclosure system that responds to the Central Park exposure, and then saving some costs with GFRC on the north facade. When these buildings were being built, the neighbors were saying that they were making a mistake, that the form kept slipping. And it actually came across as a very elegant solution, we think, with the expression we were looking for. And our motivation was to look at the structure of the cellular structures of the sponge that you saw in the original photograph. The next project, you can see the first basket weave building on the left, and then the structural expression of the tilt for D23. The client then asked us to do something even more iconic. And what's unique about this project is if you look at basically the armature of the human body and the spine and how everything is cantilevered off the spine, working with David Scott at the time with Arup, we developed a structural solution that allowed for us to do this twisted tower on D24. There were three aspects to this project that actually make it work. The first is we have a cylindrical core in the center of the building. The second is that we have penetrations in that core that are placed in a running pattern along the facade. The third is that we have cantilevered walls allowing for us to have column-free space in this honeycomb configuration that you see. So if you look at the honeycomb, if you look at the spine, it allows for us to do this building design and save about 10% on the structural cost for the building and making it more affordable. So in these towers, we rotate the floors 2 degrees per floor, and we've seen a lot of twisted, tilted, and turning towers since the Tall Building Council had their conference in Chicago 6 years ago. And this was HOK's contribution to that building type. And right now the project is on hold, but the notion was that with the cylindrical core and with this honeycomb of load-bearing walls, which are then tied together with a ring beam that's post-tensioned, we were able to create column-freed space as opposed to a lot of the tilting towers that you see where there are columns on the exterior of the facade, and those columns basically follow the twist all the way up on the diagonal. So the major components of the design here was a composite building system of the cylindrical core, the 5 shear walls that rotate from floor to floor, creating essentially a honeycomb. And then the other key was we needed an exterior cladding solution that was affordable with this complex geometry. You can see the unit plans and the twist, and essentially the MEP system sits within a slot that follows the slope of the exterior curve. Here is an example of the geometry in the honeycomb, the structure that's expressed in the facade and in the enclosure system. And then some views of these towers that we did in-house. And this is one of my favorite views because you can see down at the lobby level, there are actually no columns whatsoever. The entire building is cantilevered off the core. And by creating this torque, we've minimized a lot of the lateral wind loads to the building as well. In terms of the enclosure system, the only variation to the rectilinear design, actually this facade the glass is captured at 3 points, and the frame accepts the 4th corner. We only have 12 different glass sizes in this building, which allowed for us to come up with an economical solution. The 4th project in Songdo is the Convention Center Hotel. And going back to biomimicry, we looked at the cactus. We looked at the self-shading that happens with the cactus and the fact that within the grooves of the cactus, you actually have thermal comfort within that zone. So for this 32-story building, we focused essentially on how to shade the building before the sun gets to the skin itself. The resulting design saved about 25% to the energy loads of the building, and this is the first LEED non-smoking hotel in Korea. And the building orientation was set in the master plan, and so we created essentially these very large cantilevered blades and a bay window system that directed the facades away from the sun and shaded the sun. The bundling of 4 floors allowed for us to actually play with the scale of the building in the context of the rest of the city. And this is the built work. So these 4 projects were all done all at the same time within a 2 to 3 year span while we're working with the Biomimicry Guild and looking for ways that we can actually take some of the cues from nature and look at ways that we can modify the architecture to deal with heat gain, to deal with the cladding systems, to deal with the structural systems, and to come up with cost-effective solutions to basically minimize the footprint of the building in the landscape. So our research is really just beginning. We understand with Janine Benyus that nature really has figured it all out. And the next step for us is to go from passive design to looking at our building systems, to looking at our net zero and zero carbon buildings and looking for ways we can learn from nature and find organic forms and look at our building systems and our architectural solutions. This is just one additional tool that we have to inform sort of the randomness of how we actually approach design globally. Thank you.